Hello everyone, welcome back to the good stuff that we've been doing. Here we are already familiar with the definition of E, which is the limit as n goes to infinity of 1 plus 1 over n over all to the power of n. Now, but I would like to point out something interesting here. If we take n to be equals to infinity, 1 plus 1 over n goes all to the power of n is actually equals to, because as n goes to infinity, 1 over n goes to 0, so this is just 1 to the power of infinity. Now, most students in calculus will understand that this is actually undefined, but if you're not careful, you are going to define this to be equals to 1, because we already learned that 1 raised to the power of any number is actually equals to 1, but this is true except for the case whereby a is equals to infinity. So this limit, this e is not 1, as you will claim. E is not 1, and here is why. If even for the smallest case whereby n is 1, in this case e is actually, e tends to be like, this shows that e is bigger than 2, e is greater than 2, because if you set n equals to 1 plus 1, but here we're taking n to be greater than 1, so e is actually bigger than 2. Now the theorem is that 2 is less than e less than 3, so e is a number between 2 and 3, but we're not going to go into that for now. Our interest here is a case in calculus whereby we examine the two series, which is e is defined to be 1 plus 1 plus half plus e is the factorial plus 1 over 3 factorial, and then the pattern continues up until infinity, and then the series of e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and then we push this to infinitum. Now these are easily derived by Taylor's theorem. This is something you learn in calculus 2 or 3. So this Taylor's theorem, calculus 2 I believe, so this Taylor's theorem is being used to derive this series, but here we're going to do this without calculus. We're going to use the binomial theorem to derive this series, the binomial theorem, and I will state the binomial theorem as follows here. Here we define, let's say, a plus b when it is being expanded to the power of n, but usually when it comes to the binomial theorem, we don't write a plus b, we write actually 1 plus x. Actually 1 plus x, because we can always factor out a to make this 1 plus x. So this is general theorem of binomial theorem, that 1 plus x to the n is 1 plus nx plus n minus 1 all divided by 2 factorial x squared plus n minus 1 multiplied by n minus 2 all divided by what, 3 factorial x cubed, and the pattern continues this way. So we're going to expand 1 plus 1 over n to the power of n. Now this is the case whereby x is equal to 1 over n and n takes the value of x. So in this case we have 1 plus 1 over n multiplied by n as the first line shows. In this case we are going to have n times n minus 1, so we have n minus 1 all divided by what, 2 factorial, then 1 over n all squared. Then we are going to have n times n minus 1, then we have n minus 2 all multiplied by 3 factorial 1 over n all cubed. So the sum continues to infinity, but in this case here 1 over n times n is 1, so this is 1 plus 1. Then we are going to add this to, this is just n minus 1 over 2 factorial, this is 1 over n squared plus n minus 1 n minus 2 over 3 factorial, this is 1 over n cubed up to infinity. Now this is what I will do. This is 1 plus 1 plus, this is n squared 1 plus 1 over n. This is how I will write it, all divided by 2 factorial 1 over n squared. This is mean that if we can factor out n, this n times n is n squared, n times n is n, so if you factor out n squared, you find that you have n squared plus n. Okay, this is a minus here, so this is a minus here, so we have a minus. I fixed it. Nope. So the next part we'll be having n cubed. So we have 1 minus 1 over n and 1 minus 1 over n squared. This is okay, 2 over n squared, all divided by what? 3 factorial 1 over n cubed, and then we continue to infinity. All this should tell us is this. We notice that we define e to be the limit as n goes to infinity of 1 plus 1 over n all to the power of n, right? But we are, this 1 plus 1 over n to the power of n, this is the expansion. So when n goes to infinity, what do we have? Notice that n squared cancel out already. But when n goes to infinity, all this goes to 0. So all this goes to 0. The pattern will continue in that fashion. So what we'll have is that the limit as n goes to infinity of 1 plus 1 over n to the n, which is e, will equal to 1 plus 1 plus what? 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial, and the pattern continues upon ad infinitum. Okay, so this theorem is usually derived in calculus 2, but we are able to prove it using a simple binomial expansion. And what about the other case of e to the x being equals to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus this ad infinitum, like going to that part. Now e to the x actually is equals to the limit as n goes to infinity of 1 plus 1 over n all to the power of nx. So in this case n is being replaced by nx. Now obviously by binomial theorem we know that 1 plus x to the power of n is 1 plus nx plus n minus 1 over 2 factorial plus n minus 1 n minus 2 over 3 factorial, and we continue that fashion. So in this case here, the case of 1 plus 1 over n to the power of nx will be 1 plus 1 over n. We are going to multiply by nx here, plus then we have nx minus 1 all over what? 2 factorial. Then we have 1 over n all squared plus nx minus 2 minus 1 first, nx minus 2 over what? 3 factorial 1 over n to the power of 3, and then we are going to continue up to infinity. This will be equals to 1 plus x obviously. Now what do you have here? But we can always factor out x to get this is equals to plus n squared x squared. We have 1 minus x, I believe. Yeah, 1 over nx. Because when you multiply it out, you have n squared x squared, then you have nx. Yeah, so that checks out. So we have let me divide by, we're dividing by 2 factorial, then we have 1 over n squared plus here we are taking out n cubed x cubed, then we are doing 1 minus 1 over nx, 1 minus 2 over nx, all divided by 3 factorial 1 over n. Okay, that is 1 over n cubed, right? This is 1 over n cubed. Then we are going to infinity. I won't list the higher powers there. So this is equals to, notice that the squares, let me put a different color. Let's try, okay, yeah. So let's see that this n squared, they cancel out. Then these guys, when n goes to infinity like before, these guys go to 0. So this is, so the limits, let me just write it properly. So hold on a second. We are going to take the limits this time around here. So the limit when n goes to infinity of 1 plus 1 over n to the power of nx is equals to 1 plus x first of all plus this is x squared, because this goes to 0, so this is x squared over 2 factorial plus this will be x cubed over 3 factorial plus up until x to the n over n factorial, and we go to infinity, right? So we have derived 2 results so far, and the first one is that e is equals to 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus up until 1 over n factorial plus infinity, and that e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and we'll do this to x to the n over n factorial plus continuously. Notice that there will always be some small remainder here, but I purposely did not cover this remainder terms because I find they will be too technical for this video. But maybe in some later chapters we're going to discuss the remainders and the relation to e and e to the x. But for now we're going to stop here, and obviously we in calculus you do this with Taylor's formula, the Taylor's theorem. This is what you do it with calculus, but here we just use the simplest binomial theorem to work it out. So thank you for watching, and please do have a nice day and take care. Please subscribe to the channel. Bye.